In section 2.2, we are going to talk about some applications of the radian measure. The length of an arc on a circle depends on both the angle of rotation and the radius length of the circle. So this arc length here, S, it depends on two things. It depends on theta and it depends on the angle of rotation. Now here's what we know. We know that the circumference of a circle, which is the distance around the circle, is given by the formula c equals to 2 pi r. But let's say we don't want the whole circumference. We just want a small portion, so this portion of the distance around the circle. So that distance depends on theta. Okay, so the angle of rotation determines this distance. There are 360 degrees in a circle, and if theta subtends arc S, which means that arc S is created by angle theta, then the length of arc S will be the same proportion of the circumference that theta is of 360. So we are going to say that the arc length S is going to equal to the portion of the entire circle that theta is, that's theta over 360, times the circumference, which is 2 pi r. Now remember that in degrees, 360 degrees equals to 2 pi radians. So if you replace this 360 with 2 pi, then this gives us the length of the arc S is going to be theta over 2 pi times 2 pi r. The 2 pi's cancel out, they divide to 1. So the arc length S equals to r times theta. But because we put 2 pi in radians, theta has to also be in radians. So the first formula we have to know is that the arc length S is given by r times theta, where theta is the angle in radians. So we're always looking for theta in radians, multiply that by r, and that gives us the length of the arc S. So here's an example. In a circle of radius 12, find the length of the arc. So anytime you're looking for length of the arc, and I'm going to write this here. Anytime we are looking for length of the arc length, we're always going to use a formula S equals to r times theta, where theta is in radians. So you're looking for the length of any arc of a circle, you use this formula S equals to r times theta. So let's take a look at this. We have S equals to r times theta. We know the radius, it's 12. All we're missing is theta, which you know is 45 degrees, but theta has to be in radians. So we're going to take 45 degrees, multiply that by pi radians over 180 degrees. 45 goes into itself once, it goes into 184 times. This will give you pi over 4. So if you multiply by 12 times pi over 4, 4 goes into 12 3 times, and we're going to get S equals to 3 pi. So the length of this arc is going to be 3 pi. Next example, in a circle of radius 3 centimeters, find the length of the arc that subtends an angle of 2 radians. Now once again, anytime you have the arc length of an arc, immediately you're going to use this formula S equals to r theta. There are going to be many formulas in this chapter, so we have to know which formula correlates to which statement. So the arc length always is going to be r times theta. Okay, so here's what we know. We know the radius is 3 centimeters, so I'm going to put in 3 centimeters for the radius. My theta is 2 radians. Now this time it's already in radians, so that'll be 2 radians. So my arc length is going to be 6 centimeters. If I were to make an illustration of this, my angle is going to be 2 radians, and then my radius r is 3 centimeters. I always multiply theta times r, where theta is in radians, and I get 6 centimeters. Okay, now let's do something a little more complicated. We want to find the distance that the Earth travels in one day in its path around the sun. Now we're looking for the distance. So imagine that this is the Earth here, and this here is our sun. We know that our Earth rotates around the sun. So the question is, so it takes the Earth 365 days to complete a rotation. So it's going to go around the sun, in 365 days. So that's gonna be the circumference of this path. The question is, how far does the Earth travel in one day? So in 365 days, it travels that entire distance. If this represents one day, and I know that's more than one day, but I'm just to, for demonstration purposes, we want to know the length of this path, where this angle represents one day. Now remember, this angle is going to be theta, which we don't know what that is yet. We do know that the radius is 93 million. So the distance between the sun and the Earth is going to be 93 million miles. Anytime you want arc length, the formula is going to be r times theta, and we know half of this. We know that r is 93 million miles. Million is 6 zeros. Okay. So, and you know what, actually, because it's given in 93 million, I'm just going to keep it at 93, and we'll say that it's in millions. So we're going to keep r at 93, and we'll say that's in millions. So we have 93. All we're missing is we're missing theta. So we want to know, what is that angle in one day? What is the angle of rotation that the Earth travels? So here's what I know. When the Earth goes all the way around the circle, so when the Earth travels around the sun, that's going to be 360 degrees. And to do this, it takes the Earth 365 days. So the question is, what's the angle of rotation for one day? So if the Earth takes 365 days to go 360 degrees, what is the angle of rotation for just one day? That's a proportion. So the proportion is going to set up like this. In 365 days, the Earth goes 360 degrees. So in one day, what is the angle of rotation? Well, that's going to be x degrees. To solve any proportion, we're going to cross multiply. So we're going to say x times 365 equals to 360 times 1. In order to get the x by itself, I am going to divide both sides by 365. And then 360 over 365, this gives me some decimal. I should have worked this out before. I did not. So now I'm going to do it on the spot. Okay, so this gives me 0.98630,137. And you want to keep as many decimals as possible until the very last step. But this is in degrees because I use 360 degrees. And I'm going to show you guys the same thing but in radians next to show you that it's easier. Now my job is to take this, so I'm going to take 0.98630,137 degrees and multiply this by pi over 180, because remember, our angle theta has to be in radians. So if I do this, then I get a very, very small value for radians. I'm going to get 0.0172142. So my theta in radians is going to be 0.017 2142 radians. Now, another way of doing this, if I wanted to do the same thing, but in order to help me prevent that last step, I can do the same thing. I can say in 365 days, the Earth goes 360 degrees. But because I know I need my answer to be in radians, instead of using 360, I can just use 2 pi radians. Because remember, 360 degrees is equivalent to 2 pi radians. And then I'm going to say, so in 365 days, the Earth makes a rotation of 2 pi. In 1 day, what is the angle of rotation? And again, you cross multiply. So we're going to say the x goes here, the 2 pi goes there. So we have x times 365 equals to 2 pi. And then I'm just going to divide both sides by 365. And when I do that, I get the same thing. I get 0.017, 2142. But of course, this method is a lot easier. If I multiply 93 times 0.017, 2142, I'm going to get 1.601 million miles. But I need this to 1 decimal place. This will give me 1.6 million miles. All right, let's take a look at another example. Find the distance along an arc of the surface of the Earth. So we're looking for arc length. Anytime I want arc length, first thing I'm going to do is I'm going to put r times theta, so I know what I'm looking for. I'm going to encourage you to always start with the formula. Even if you blank out, start with the formula. I want arc length. My formula is r times theta. So it says, find the distance along the arc of the surface of the Earth that subtends a central angle of 10 minutes, and the radius of the Earth is 3,960 miles. So, okay, so this radius is going to be 3,960 miles. So half our work is done. We know that that's 3,960. So the question is, the central angle of 10 minutes. Now we don't want minutes. We want this to be in degrees and then eventually in radians. So here's what we know. We know that 1 minute is equivalent to 1/60th of a degree. And so we want to know 10 minutes is equivalent to how many degrees. And once again, we can make this into a proportion. We can say 1 minute is equivalent to 1/60th of a degree. So 10 minutes is equivalent to how many degrees? And we cross multiply. X goes to the left, the 1/60 goes to the right. So we're going to say our x is equal to 10 times 1/60. If you multiply 10 times 1/60, you're going to get 0.166666667. It's 6 repeating, so I can just put that at 0.7. Or if you want to keep this as a fraction, you can just keep this as 1/6. If you reduce this, you get 1/6. But this is in degrees. This is in degree form, not in radian form, because look, it says 1/60th of a degree. We need theta to be in radians. So now we got to convert this into radians. So you can either take the 0.16667 or 1/6 of a degree, whatever you prefer. So I'm going to take the decimal form 166666667, multiply that by pi over 180 because I need to convert this into radians. And in radians, this is going to be, give me a quick sec, multiply that by pi, divide that by 180, and in radian form, and you want to keep as many decimals as you can, that's going to be 0.00290,88821. Keep as many decimals as you can. So now I want to multiply our radius by the angle, which is going to be 0.00290,88821. And if I do that, I'm going to get 11.519 miles.